First part of this unit is dealing with radical functions. A radical function is more than just the square root graph that we began with. You can put anything inside that square root, any function. And I mean, we were introduced to very basic radical functions when we did our transformation unit, right? We had our square root of x graph. And we learned how to do all the transformations with the square root of x graph. Okay? We learned that if you wanted to do the square root of x plus 4, you could just take that square root graph and move it 4 to the left. But what we're going to learn in this unit, that if we want to square root any graph, if we know how to graph the inside equation, in this case, inside of the square root is x plus 4. You know how to graph x plus 4. It's a straight line. And if you know how to graph x plus 4 and use the ideas that we did in that first activity, you're going to be able to graph the square root graph. It works like this. There's the graph of x plus 4. We know from this activity that in yellow, the only time it's the same is if you have the square root of 1 or the square root of 0. So we go to our graph, and the first thing we mark is, where is it 0? Where is the y value 1? Because if I square root that, it's going to stay 0 and 1. The next thing you're going to do is you'll probably do some mental math and say, are there any other nice values I can square root easily? Like, I know how to square root 4. Ooh, I want that red. There we go. I know how to square root 4. Square root of 4 is 2. So I have that as an easy point that I can grab. But we're going to use these ideas that we had here from the first part. Usually, when you square root a number, it's smaller. That happens if you're square rooting something bigger than 1. That shows up on the graph by any time the y values in the red graph are bigger than 1, your square root graph has to be smaller. So it's got to be underneath the red graph. Does that make sense? And this new idea for many of you, right? Many of you, when you probably thought before today's class, wouldn't think I can square root a number and get something bigger. But you can. When you square root anything between 0 and 1, you get something bigger. That shows up the fact that this blue graph is slightly above the red graph when the y values are between 0 and 1. And this gives us a new technique for graphing the square root of x plus 4. At this point, I would say, for square root of x plus 4, I think I'd rather use transformations. Really simple to move it 4 to the left. But there are some situations that I'd be like, oh, I remember places you guys made mistakes in transformations. Oh my, this next one here. This was like classic mistakes in transformations. Why? Because if you were doing this one in transformations and you had a horizontal reflection and a horizontal translation, you had to remember to write it in factored form first. And sometimes you forgot that. So if you were using transformations, you would have a horizontal reflection, and then it would move 2 to the right, but the main mistake is everybody would see the plus 2 and move it 2 to the left. But now if we use the new technique where we graph the inside, negative x plus 2 is a straight line with a y-intercept of 2 and a slope of negative 1. It is not hard to find out where the red graph is 0 and 1. It's not hard to find some other nice points. Oh, here it's 4. Square root of 4 is 2. And then use the fact that when you square root something bigger than 1, it's got to be below, it's got to be less. And when you square something in between 0 and 1, it gets bigger, so the blue graph is slightly above. And this is the first part of this unit. We are going to be able to graph the square root of anything as a result. And on the next page, we can highlight these steps and sort of, right? The first idea that you will always use is any place where you have 0 and 1, those will be on both graphs. Those points don't change because the square root of 0 is 0, the square root of 1 is 1. For the second bullet, I'm going to rephrase this on the other side. It says where the graph lies between the graph of y equals 1 and the x-axis, the graph of the square root of f of x lies above the graph of y equals f of x. Where the y values are between 0 and 1, the square root graph is above the regular graph. So if your y values are between 0 and 1, then your square root graph is above y equals f of x. The next bullet where the y values are greater than 1, the square root graph is below the regular graph. So basically the three things that I looked at in that activity at the beginning form the basics for how you're going to graph any square root graph. And the last bullet here, we're just going to make a note that you can't square root a negative. You know this. You know that you can't square root a negative. How does that show up in the graph? Well, if we look at the graphs that we just did, and I take out my highlighter, and I highlight where the red graph is negative, notice we didn't draw anything for the square root graph, because you're not allowed to square root a negative number. So the blue graph does not exist where the red graph was negative, because it's just not allowed. So with these things in mind, we can go to example 1. Example 1 says, here's some graphs. Can you graph the square root graph, even if you don't know what the original graph is? Yes, it's not hard. We're going to use those big ideas. We're going to say, well, if I square root 0, it's 0. If I square root 1, it's 1. Those will be the first 2 points you always find. Where's my y value 0? Where's my y value 1? Then I would suggest, if there are any other nice numbers you can square root, do them right away. For example, I know the square root of 4 is 2. I know the square root of 9, there's 9 up there, would be 3. So if there's nice numbers, you can square root them right away. Then it's pretty obvious that this part is the part that's going to be below. Oops, I need to make this over just a bit. There we go. It's pretty obvious that that part is going to be below, and that's true. Anytime you square root a big number, you're going to get a smaller number. But this section between 0 and 1 has to be slightly above. So between 0 and 1, when you square root a number between 0 and 1, it gets bigger. We show that on a graph by being slightly above. Whenever it's bigger than 1, square rooting it gets smaller, so we show that on the graph by the blue graph being below the red graph. here are, if there's going to be mistakes that you're going to make in the graphing, usually they happen with this little section that's above. I'll show you some common mistakes, and I'll make them extra exaggerated. Extra exaggerated mistake number one. You cannot go back in time. That is not allowed. That's really back in time. Okay? But even a little bit sometimes happens. You want it to go above, and you're just like, oh, it's easy to go above if I go back in time. No. So that's mistake number one. Mistake number one, you want it to go above, and you actually go above 1 in the process. When you square root a number between 0 and 1, it gets bigger, but it never gets bigger than 1. Right? None of our answers when we square rooted, they always ended up being another decimal, less than 1, but bigger. So sometimes you are going to find, when you do it bigger, so we can't go back in time, it's got to be above, there's very little room to do that. Sometimes the best you can do is almost draw it right on top of the line. I will accept that. No, if you run out of room, but we can't go back in time or over-exaggerate. For this one, the domain of our blue graph is bigger than or equal to 2. The range is bigger than or equal to 0. For part B. Okay? Again, for square root graphs, if you're given the graph, right, you will always start by finding out where is the y value 0, draw that point. Where is the y value 1, draw that point. Because square root of 0 is 0, square root of 1 is 1. Are there any nice points? Well, if we extended this a little bit further, we would get to 4, right? So square root of 4, you can kind of estimate that it's going to be 2 there. Between 0 and 1, your graph is slightly above. Then after, it's below. We never draw an arrow on the right-hand side here, because your red graph is going negative, and you can't square root a negative. So 0 is where it starts. There would be an arrow on the other side, because the red graph keeps going. Domain of this one, x is less than or equal to 6, and the range, y is bigger than or equal to 0. One question to circle, you can question circle. Question 5 from the homework.